Video, we are going to review some information from mods 3 and 4. Now in 3, it talks about factorization, divisors, multiples, divisibility. So let's take a look at our first problem here. It says, using rules of divisibility, determine whether 89,001 is divisible by any of those numbers. Now, a few numbers we can tell really quickly. If the last digit is not divisible by 2, then it is not even. So it's not even. So if it's not even, anything that is also even, like 4 wouldn't go into it, 6 wouldn't go into it, 8 wouldn't go into it, 10 wouldn't go into it. Because if 2 doesn't go in, no combination that includes a 2 would go into it. But you could check. If you divide any of those into it, you're going to get some decimal value kind of hanging off the end, point something that tells me, oh, it's not divisible. Now let's check 3. The rule is kind of interesting. If you do 8 plus 9 plus 0 plus 0 plus 1, if you add up the digits and that number, in this case 18, if that number is divisible by 3, which it is, then the whole number is divisible by 3. If you put into your calculator 89,001 divided by 3, it comes out perfectly, okay? So we know it's divisible by 3. Now let's check 5. Well, for a number to be divisible by 5, it should end in 5 or 0. This does not. So we can cross that one out. Now, it might be divisible by 9. And so if you divide that number, we said earlier, by 3, we get 29,667. And if you do the trick again, if you add up the digits, 2 plus 9 plus 6 plus 6 plus 7, you get 30. Well, those digits add up to a number divisible by 3, so we should be able to divide it by 3 again, evenly. Because if you divide it by 3 twice, 29,667 divided by 3 is 9,889. So 9 is also divisible. And then, I would try, does 3 work again? It doesn't, but, so there you go. Now let's talk about prime factorization. So prime factorization, what I like to do is use some of those rules that we were talking about before. That divided by 2, So I usually try 2 and 3 and 5, kind of to get started. If you notice, it's an even number. I'm going to kind of divide long down so that we can just kind of look at what's there. 2 goes into 180, just cut it in half, 90 times. I still can cut it in half, so divide by 2 again. I get 45. Now, I can't divide that evenly by 2, so because of that, I look at my rules for 3. I see if does it end in a 5? It ends in a 5, so I know it's divisible by 5. And so 45 divided by 5, we know, is 9. And then 9 is 3 times 3. So if we think about 180, it's going to be 2 times 2 times 5 times 3 times 3. If we write it using exponential notation, we have 2 2s, a 5, and 2 3s. So you could put an exponent on a 2 and an exponent on the 3. And then lastly, in mod 3, the greatest common divisor and least common multiple of 220 and 400. Now, I would do exactly what we did before. Let's break it down, okay? So I know I can cut that in half. I know I can cut that in half. Then I can divide by 5. And so 220 is 2 squared times 5 times 11. Now let's do the same thing for 400. I can cut it in half. I can cut it in half. I can cut it in half. I can keep cutting it in half. Oop. And then that is 5 times 5. Okay. So 400 is 2 to the 4th times 5 squared. Okay. Now let's talk about greatest common divisor and least common multiple. The greatest common divisor is the largest thing that can go into both. Okay. So then, even though it has the word greatest, we really can only use the things they have in common and the smallest amount that they have in common. So they have 2's in common. The smallest amount is 2 squared. They have 5's in common. The smallest amount is just 5 to the first. So it would just be 4 times 5, or 20. And then you can check. 20 goes into 220 evenly, yep. 20 goes into 400 evenly, yep. And that's the largest number that will divide into both. Now, least common multiple, you use the largest, whether it appears in either location. So the largest thing, or the power, I guess I should clarify, the largest power I see on a 2 is a 2 to the 4th, so I got to include that. The largest power I see on a 5 is a 5 to the 2nd. I have to include that 11 because the largest power I see of one of them is just one of them. And then you're going to multiply 2 to the 4th times 5 to the 2nd times 11. And you're going to get 4,400. Now you can check. 220 does go into that evenly. 400 also goes into it. So that's a good check. Can we divide those numbers into it? Then you probably did it right. Okay, so that is mod 3. Some things about divisibility, breaking up what's inside of a number. Now let's look at mod 4. Mod 4 information is about signed numbers and order of operations. So first let's talk about signed numbers. The rule of signed numbers basically is if 2 numbers have the same sign, so if the signs match, you're going to add them and keep the sign. That does not say keep the sign. There we go. Sometimes talking and writing is, not my best thing. If the signs are different, you're going to subtract them. Keep the sign of the larger value thing. Okay? So if you look at number 1, if we're adding a negative 17 with another negative 17, they have matching signs. You can also think about that as negative 17 minus 17, but either way, we're going to add them up, keep the sign. So the answer would be negative 34. Now let's take a look at 2. Subtracting 9 minus 20, the 20 has that negative with it. So we would consider it different signs. So we're going to subtract, get 11. 20 from, or 20 minus 9 is 11. But the 20 is the larger value, so we're going to keep that negative. Okay, and then this one, now the rules for multiplication and division are different. 2 negatives make a positive, so when we're multiplying or dividing, 2 negatives, so a negative times a negative, or a negative divided by a negative makes a positive. Only one negative stays negative. So here we have 2 negatives multiplied together. We know the answer is positive, and then just do the math. 8 times 5 is 40. 4, we have a negative divided by a positive, so we know the answer is negative. You're done with that, throw that away. And then do the division. So 300 divided by 12 is 25. Okay, let's talk about order of operations for our last one here. Please excuse my dear Aunt Sally. So I think about it as really being 4 steps. First step is parentheses or kind of grouping. Second step is exponent. Third step, we're going to multiply and divide from left to right. Whichever comes first, we do first. And then finally, we're going to add and subtract from left to right. Whichever comes first, we're going to do first. So let me write this problem just a little bit bigger. I'm going to write it like they did, okay? So we are going to do the exponent. Now, this negative is not included in this calculation. It is 3 squared, which is 9. So we're going to write negative 9 times 5 minus 2. Now let's talk about this. This is included, so that means negative 2 times negative 2 times negative 2, which 3 negatives are going to stay negative. 2 times 2 times 2 is 8. Now we are done with those two, and we are going to multiply or divide from left to right. Negative 9 times 5, a negative times a positive is a negative. For here, negative times a negative is a positive. 2 times 8 is 16. So what's great about multiplication or division is that you can do the sign. You know 2 negatives make a positive, 1 negative stays negative, and then do the actual math. Now, for this last step, to add negative 45 and 16, they have opposite signs. We're going to subtract the values from them. So you just subtract off 16 from 45. You get, don't get that. We get 29. And then we have a negative left over. And the reason we have a negative is because our larger value, we subtracted and kept the sign of the larger absolute value. So there you go. So that's a little bit about mod 3 and 4. Hope that helps you. Have a great one.